Okay, let me see and try this again. I'm going to try to show you how to create the graphs that I wanted you to graph last week, or to make actually in Excel. So let me first open a new Excel spreadsheet. We had age, frequency. Now just put a few numbers, doesn't matter. 14, 16, 18, 20. Not sure why there are only odd even numbers, but okay, doesn't matter. 4, 6, 7, about 7, 5, 3. So here I have a list of frequencies, so 4 people. They have an age of 12, 6 of 14, and so on. You've done this last week, so I'm going to create a bar graph. So let's block it, let's highlight it, and insert a graph. We can go to recommended charts, we can go to bar charts, column group charts. Let's see what we can do here. So more column charts, and something is coming here. I like this one. I hope you picked it up. Column, and then I looked around for more columns. You see here the age of 12, there are 4 people, 14, there are 6 people. So let's click on this, and voila. We have here the frequency against age. I didn't put a label on the y-axis or the x-axis. I could have done it. This was the first graph I was looking at. The second graph was I wanted to create a probability graph. So what's the probability when I pick anybody that their age is 14 years old or 16 years old? So I'm going to look at the total number of people I counted. So in Excel, you can use sum. Let's sum all these people. 32. Let's divide. So is equal to, let's divide the 4 by 32. And that's the probability to get 12. Let's copy and paste. And then finally, I have 2 of them in Excel. You can drag down the rest. So here I have the probability. So this is the probability. Let's again create a graph. So I'm going back to insert. We were at columns, more columns, and let's take this one this time. Okay, there we are. Now I don't have what I actually want, because I have the frequency in the same graph as the probability. But I only want to see the probability. Again, I didn't put a title, could have done that. Could do that later by double clicking on it. I'm going to highlight B, as you can see. If I right click, I can hide it. Voila! Now I have the probability density, we often say. So although the numbers are not too clear, if I pick somebody at random, the probability that the one is 16 years old is 0.22 or so. If you look at the graph, if you look here, 0.21875, 0.125, that somebody's 12. So now I've changed that frequency graph into a probability graph. Now I want to actually show how does that develop. What curve am I looking at? I'm going to try to introduce a trend line. Add a trend line. So I right click, add a trend line. Now, obviously I don't want a line, as you can see. I want a type of a curve. The easiest one is to take a polynomial. Now, it's almost there already. Do you see that? So let's take a bit a higher one. No, I like this one most. Done. So here now, I see a probability density curve. that looks like a Gauss curve, it looks like a bell curve, whatever you want to call it. That is the one we are looking at. If you look at the Gauss curve, you see that the mode, the mean, the median, they're all here in the middle. Only then you can use what we call here a normal distribution. This graph shows me that the left side is half of all my numbers and the right side is approximately half of all my numbers. It's symmetric in the middle, from the middle, so I have a normal distribution. If you don't have something like this, you actually can't use the normal distribution. Social sciences, they do it all over. If you have a skewed graph, one that is completely to the left or completely to the right, they still use normal distribution. But in mathematics, you shouldn't, because it doesn't give you the right conclusions. So I hope you saw what I did. I'm recording this so that you can re-look at it. Maybe it was a bit too fast, but let me actually stop it.